Hi students, in the last video we were able to understand how the addressing modes we represent in the instructions of 8051. So that now we'll come to understand the instruction set. We can define the instructions in different modes, like what are the addressing mode we came to know. With respect to those addressing mode, we can represent the instructions. So some of the instructions are invalid with respect to the addressing mode, so that is also will be identify the formats. So in 8051 we have an 8-bit opcode. So as we know that instruction format, we have an opcode and operands. So that there are 256 possible instructions, of which are probably we differentiate with one. The first one we have data transfer instruction. Data transfer. So in this instruction normally we came to understand that data can transfer from one register to another register, or one memory to another register, or address to address register. So these are the instructions we are seeing. Probably we can come to know that data can store temporarily in some of the memory location. So then we can retrieve or read back. So that these are in this group we are studying those instructions. Next, in the second one we have the arithmetic instructions. So in arithmetic instruction we can know that all the addition, subtraction, divisions. So these are the instructions we are learning here. So all the arithmetic instructions done in the accumulator, as we know that. So how we can represent the instructions under arithmetic group in different form of addressing mode. So the third one we have the logical instruction. So here we can learn the some of the logical instruction AND or XOR gates. Along with that we can modify the ports or modify the flags by using some of the logical instruction. Here we are learning about some bit logical instruction, so that in this also we can learn about some of the rotate instructions to find out the value with respect to bit. So the fourth one we have the some boolean instruction. So here we are studying about some of the bit operated instructions to operate with the bit, like we want to set the particular bit, I want to clear the bit. So such kind of instructions we are seeing in the boolean instructions. Next we have the branching instructions. So here we are using some of the conditional branch or unconditional branch. So like as we know that jump instructions, this all comes in this branching instructions. As well this also we call it as machine controlled instructions. Machine control instructions. So like some of we have the if the flag, whatever the carry flag is set, so jumps to some other location or something to check the mission status, and then we can branch the instruction. So like otherwise we can do like for example we need to check comparing the two register. If the comparison is happening, if it is both are equal or that we can identify as a 0 flag, so then the branch has to be happen. So these are the instructions we are discussing in this group. So we have the 5 group of instruction. See, these 5 group of instructions, we can represent the instruction format in different addressing modes. Let me start with the data transfer group of instruction. That is what we call it as a move instruction. See, the move is an opcode, so that this instruction copies the data from one to another. So how this format, we'll see that. So there is a format is data, whatever the move, destination and source. So the content of source content is copied into the destination. This is the operation of this, remember. So move, destination, comma, source. If you have interchanged, then that will be a different. Clear? So we'll see that different form of instructions with respect to move instruction. So here I briefing all the format. Let me go with single 1 by 1 by format of addressing mode. So here I can identify the immediate data. I move to the accumulator, or accumulator content copied into R0 register or R1 register and R2 register. Like immediate data I copied into R3 register, from R3 to A register. So likewise I can copy the contents or move the data into some particular register. So let me see the some different form of instruction. We have the move, we have an accumulator. Let me see some source. What are the registers we have? First we have some Rn register. So Rn register represent R0, R1, like R7. So source can be any register. Example, move A comma R2. So this is the format. So A destination should be anything. The source can be any register. Okay. So destination should be a accumulator. Source should be a Rn register. Okay. So the next we have that we can represent the direct addressing. So this is the addressing mode is register addressing, because both the operands are register. So now we'll have the register. The source should be a direct addressing. So let me see the example. Move A comma some 30H. So 30, it is a address pointed to the RAM, internal RAM. So the content of 30H is moved to the accumulator. Okay, the operation of this is the content of 30 is moved into the accumulator. This is the operation. So here one source register should be a direct and the destination should be accumulator. So the next we have indirect addressing. So as we know that Ri, it has only the R0 and R1. These two registers are the indirect registers. So how we can represent? Example, move A comma at R0. So here the operation performing is the content of R0 holds an address. That content, the data is moving into the accumulator. Okay, so here for example in this R0 pointed to the address, that content, the data is moved to the accumulator. Okay, so this is indirect addressing mode. Next we have one more example, like this indicates that immediate. Example, we have move a comma hash some 25h. So this is immediate data. It copies here to the accumulator. So the the value 25h is copied into the accumulator. So what my intention is, see, this is one format, move a comma source. Source can be in this different addressing mode. One we can be any content of register and the direct addressing mode and indirect addressing mode and immediate addressing mode. In all the register addressing mode, in all the addressing mode we can represent the source when the destination should be a accumulator. Okay, similarly next we'll have the one more format. Let me have some one more, like move. We'll take the Rn as your destination. Okay, and this should be a source, can be, what other source can be? See, source can be, we have some accumulator, it possible, like example, I can write an example, move Rn comma a. Next we can have the direct addressing. Example, move Rn comma some 30h. Remember, if I am not mentioned the hash symbol, it indicates that it's a direct addressing mode. So how it is working? So the content of 30 is moved into the register, like Rn in the sense, take any of these register, like I am taken as in, let's say R3. So this is also R3. The value R3 holds the content of the address pointed as 30h. Okay, similarly I can have the immediate. So like I can represent move something R3 hash 20h. The value 20h is copied into R3 register. This is the meaning. Okay, so the next, here it will not support the two addressing mode. Remember, one is Rn. So this is not possible, like move, like R3 comma R2. This is invalid. This is invalid. So I can transfer between two register is not possible. I can transfer the data between any one of the accumulator or B register from the any register, or from register to register data transfer is not possible. This should be remember. And similarly the indirect addressing mode, it is also invalid. So indirect addressing mode, we have only the register R0 and R1. So I can't do like move, like R4 comma at R0. So this is also not possible, right? So these are the forms we should understand clearly. So I'm repeating once again. So this is the one instruction, move a comma source. Source can be any addressing mode. So another instruction format, we have that move the destination is Rn register. Source can be, it can be accumulator or B register. Let me take it B also. And we can have a direct addressing mode. We have an immediate addressing mode, but not the Rn, that is Rn value. Rn is in the sense some R0 to R7. It should not be data transfer between the two register. It is not possible. And similarly the indirect addressing mode. So indirect registers are R0 and R1, so that these things also is not allowed from indirect R0 content to transfer into the any other registers. Next we'll have some one more example. We'll have that move will destination, we can take a direct comma source. So for the direct addressing, what are we can represent? One, we can represent accumulator. Example, move direct addressing mode in the sense any 30H comma accumulator. So here the accumulator content is transferred into the pointed memory location 30H into the RAM. Okay, this also possible. So the next we have direct. So move some 30H to from 50H, any address we can take, RAM area from scratchpad area, wherever we have, so that we can possible. So here the 50, the address holds in the RAM, the content is transferred into the another memory location 30H. So direct to direct it is possible. Next we have indirect. So indirect we have only R0 and R1, so that I can possible to move like 40H comma indirect R0. So here the R0 content of content is transferred to the address pointed to 40H. Okay, so next we have immediate. So we can transfer the data like 40H comma hash 25H. This immediate data I can transfer to directly to the RAM located with the pointed address, that is 25. Immediate data, it is transferred to the point located to the 40H. Okay, next similarly so what are the source we can have? So let's say first one we have the indirect with direct addressing mode. Example, we can have move at R0 comma 30H. So the content operation is some content of 30H is moved to the memory pointed the register that content it is transferring. Okay, and similarly we have the immediate, like an example, move at R0, comma, let's say 45H. The value 45 is copied into R0, pointed the address that content is transferring. So it is indirect addressing mode. Okay, and similarly we can have the accumulator register, like move at R1, comma A. So accumulator content we can transfer into the indirectly to the R1 register. Similarly we have the bit data movement of your move. How we can operate with the bit by data transferring instruction. Let's say we have the operand format like move. Here we have the destination bit, comma, source bit. So this is your instruction. So let me have an example, move C, comma, bit. So here the bit can be any ports like P1.2. Here the content of P1.2 bit is transferred to the carry flag. So the P1.2 bit content is transferred to the carry flag. So here we can use any bit addressable register. We know the bit addressable registers or special function registers. Any special function bit addressable register. Similarly, we can have the move bit, comma, C. From carry flag to we can send the bit. Let's say port, let's say I'll take another accumulator dot 2. So here from the carry flag it is transferred to the accumulator bit of 2 bit, that is D3 bit. Okay, so here also the bit can be any bit addressable register. Or some SFR registers, special function registers. So this is your data transfer instruction formats with examples. Hopes you understand. Thank you very much.